Bismillah Rahman Rahim. Assalamu alaikum, everyone. Welcome to ASTC. So, in this video, we will be looking at calculations which are related to speed, distance, and time. So, this is our subtopic 17.2. All right. So, question number one is Liz takes 65 seconds to run 400 meters. Calculate her average speed. Now, the first thing that I want you to write down is the formula that we will be using in this topic. That is speed equals distance upon time. Okay. Now we need to calculate her average speed. So we know that speed is equal to distance. Now for average speed, okay, you should know that average speed is equal to total distance over total time. Okay. So that is 400 meters divided by 65. So 400 divided by 65, that would be 6.15 meters per second to 3 SF. Okay, because this is not an exact answer. Now, how is this formula different from this formula? This formula gives you speed at a particular point. Okay. Whereas for this one, if let's say that you had a two-part journey, so you went from point A to point B, and then from point B, you went to point C. So now if I want to work out that what was my average speed between A and C, so there were two parts of the journey, each one with a different speed, each one with a different distance, each one with a different time. Okay, so what I'm going to do is I'm going to find an average speed by adding the distances and adding the time. Now, in order to use this formula as well as this formula, we assume that during this motion, the speed is actually constant. So if it was 60 kilometers per hour, then it will remain 60 kilometers per hour for a certain distance, whatever the distance is. And how much time it's going to take, so that will be worked out using the formula. Okay, so the point is that the speed is actually constant, and that is where we can use this formula. All right, question number two is Amar cycles at a speed of 18 kilometers per hour. It takes him 55 minutes to cycle between two villages. Calculate the distance between the two villages. Okay. Now, one more thing that you have to be very careful of is the units. First of all, look at the answer that is required. It is required in kilometers. So therefore, the speed is okay. Okay, if suppose the distance was required in meters, then we might have had to change the speed from 18 kilometer per hour to meters per second. Okay, so speed is okay, but the time is in minutes, so first we have to convert the time. Okay, so we know that 1 hour is equal to 60 minutes, so therefore time is equal to 55 divided by 60. Okay, so 55 divided by 60 will be okay. So this is a non-exact answer, so I'm just going to use the exact form. Okay, 11 upon 12 hours. Now we know the time, we can use the formula. So this time we have to find distance, right? So the original equation is speed equals distance upon time. So this time can multiply to the other side, so you will get distance equals speed multiplied by time. Speed is 18, time is 11 upon 12. Okay, so we can divide both of them by 6. So here we'll get 2, here we'll get 3. So the answer will be 33 upon 2. Okay, so 33 upon 2 will be 16.5 kilometers. Okay, so that will be our answer. Number 3, a train takes 10 minutes 30 seconds to travel 16,240 meters. Calculate the average speed of the train Give your answer in kilometers per hour. Okay, so you can look at the unit that it is required in kilometers per hour. So we have to change the distance from meters to kilometers. So let's do that first. We know that 1 meter is equal to 1000, sorry, 1 kilometer equals 1000 meters. Therefore, 16,240 divided by 1000 will be equal to 16.24 kilometers. Okay, so here first we'll cancel the zeros and then take the decimal point 2 places to the left. So that is my distance. Now the time. So here what we can do is, first of all, we need to convert 10 minutes and 30 seconds, right? So let's say that time is equal to, so I'm going to convert 10 minutes into seconds first of all. So 10 times 60, and then you have another 30 seconds. So 60 times 10, that will be 600 plus 30. So you get 630 seconds. Okay. Now I'm going to convert the seconds directly to hours. We know that 1 hour is equal to 3600 seconds. So therefore, time equals, 630 divided by 3600. The zeros cancel. So I'm going to divide 63 by 360. That would be 0.175 hours. Now we can apply the formula. Speed equals distance upon time. Okay, also let me write this down over here. Okay, so this is the distance, which is 16.24. The time is 0.175. So when we work this out, we will get 92.8 kilometers per hour exactly. Okay. All right. Question number 4. A train travels for m minutes at a speed of x meters per second. Find the distance traveled in kilometers in terms of m and x. Give your answer in its simplest form. Okay. So the distance must be in kilometers. However, the speed given is in x meters per second. Okay. All right. So if I want to convert my speed from x meters into kilometers, okay, so what we can do here is, we can first of all, let us convert minutes into seconds, because I'm not going to change the second part over here. Okay, this one I'll keep it the same. So let's first convert the time in minutes to seconds. So time is equal to m minutes multiplied by 60. So that would be 60 m seconds. Okay, so the time is going to be 60 m seconds. Now the speed is equal to x meters per second. In order to convert the meter part into kilometers, I'm going to divide by 1000. So that would be x over 1000 kilometers per second. All right. Now we need to find the distance. Distance equals speed multiplied by time. The speed is going to be x upon 1000, and the time is going to be 60 m. Okay. Now you can simplify. So this 0 gets cancelled from here, and then you will be left with 6 upon 100, which is 0.06 xm or mx. Okay, so 0.06 mx kilometers. All right. So this is how you approach this question. Now, why were we able to work this out in this manner? Because x upon 1000 was kilometer per second. Let me write this down in a fraction. Kilometers per second multiplied by the time, which was 60 m seconds. So you can see that the second and second will cancel out. So the only unit remaining is kilometers. Okay, remember this m is not meter. This m was m minutes, right? So this is a variable that is being used. All right. So at the end, we'll only be left by kilometers. Okay, the next one is when m is equal to 5, the train travels 10.5 kilometers. Find the value of x. Okay, so we just worked out the formula for distance, which is 0.06 mx, right? The distance, which is given here, is 10.5. Then we have 0.06, and the value of m is given as 5. So now 0.06 multiplied by 5, that will be 0.3. So we are going to divide 0.3 to the other side. So x is equal to 10.5 divided by 0.3. Okay, so that would be x is equal to 35. Okay, so that's the answer to part B. All right, so let's take a look at question number 5. On a journey, the train took 73 minutes, correct to the nearest minute, to travel 215 kilometers, correct to the nearest 5 kilometers. Okay, now if you recall, in what type of questions did we have these type of statements that correct to the nearest something? Whenever they give you a value, immediately after that they will tell you that okay, this value is correct to which degree of accuracy. So over here, these 73 minutes, they are recorded correct to the nearest minute. Okay, so you can pause the video, try to recall that what was the concept that we studied where we have these type of statements. Okay, so now let's see if you got the correct answer. This question is related to upper and lower bounds. Okay, because in those type of questions you are usually given the accuracies, that okay, to which accuracy this value was recorded. So here we need to work out that okay, if it was correct to the nearest minute means 1 minute, so we divide 1 by 2. Okay, and therefore we would get 0.5 minutes. Okay, so this is usually the process that happens, that we always divide by 2. So similarly over here, this value, which is the distance, is recorded to the nearest 5 kilometers. So I'm going to write 5 and then I will divide this by 2. So this turns out to be 2.5 kilometers. All right. Now I'm going to use these values to work out. Okay, first of all, what does it need? It says calculate the upper bound of the average speed of the train for this journey. Now, the formula is speed equals distance upon time. Now, over here, he's asking for the upper bound of speed. So if I want the upper bound of speed, that means that this value, which is a distance upon time, this should be the biggest possible value. That can only happen when the distance is the upper bound, but the time is the lower bound. Okay, so if you're confused in this concept, let's just take an example. Suppose that you already know that okay, if I take the distance to be upper bound, automatically speed will also be upper bound, right? But for the time, let's say if I ask you a question, 10 over 2 and 10 over 5, which one is going to give you the biggest possible value? So definitely it is going to be this one, right? Because if you decrease a value in the denominator, your whole value becomes a bigger value. Okay, if you divide by a bigger number, your whole value becomes a smaller value. Okay, so that is the logic behind this concept. Okay, so now that we know that in order to find the upper bound of speed, we need upper bound of distance and we need lower bound of time. So the distance originally was 215 plus, I'm going to add the value which I worked out over here. So that would be 2.5 divided by the time, which is 73 minutes. Okay, now because this is lower bound, okay, so I'm going to subtract it by 0.5. Okay, so now this becomes 217.5 divided by 72.5. So okay, so let me work this out. And one more thing, yes, my bad. If you look over here, this is minutes, right? However, we need our answer to be in kilometers per hour. So therefore, this should be divided by 60. Okay, because this is in minutes, and in order to convert this into hours, we need to divide by 60. So therefore, my answer is going to be 217.5 divided by 72.5 divided by 60. Okay, so you can also write this in bracket in your calculators. So this is equal to 180 kilometers per hour. All right. So this is the end of our topic. So I hope that it is clear and you understood the concept of speed, distance, and time. In the next video, we're going to start the distance time graphs. So I'll see you in the next video. Till then, take care. Assalamu alaikum.